Hey everyone, I'm making a really quick video to show you two different things. One of the things is really important because it will help you do assignment one. And related to that, I'm be sure to look for an updated wave file on Canvas, which I'll be posting soon after I post this video. So the first thing I want to show you is how to measure the period of a waveform. So, so let me start by, I'm in Audacity, I'm just going to generate a waveform, and I'm just deciding for this example that the frequency is 50 hertz, and we're going to make it 3 seconds long. And I do that, and so here's the whole thing. And so here you can see on this top line, we got numbers in seconds, so we've got 3 seconds. So the total file is 3 seconds long. So how do you figure out the period? And this involves zooming in on the waveform so you can actually see it in detail. And what you want to do is find like a zero crossing a point on the waveform and select the entire portion of one cycle and highlight it. And so down below, so the key is down below, you've got a bunch of different options for how to view time. Here's it's giving two numbers, the time at the beginning and time at the end. Well, we don't want that. We want the start and the length of the selection. So we don't really care about this number. I just happen to have chosen a cycle that began like 1.06 seconds in. What we really care about is the duration. So this number down here is so it's 0.02 seconds or 20 milliseconds. So you have a bunch of different options. You can't see it because it's outside of my screen capture range, but you want to make sure that it's set to HHMMSS plus milliseconds. So this is the number of hours, so it's 0 hours long, or 0 minutes long, 0 seconds long, and 0.21 seconds or 20 milliseconds long. So so you can tell from this, by doing this, you can tell that the period of the waveform is 20 milliseconds long. Yes, so the next thing I want to show you relates to some of the stuff we talked about today in terms of filter windows. So if we take the whole waveform, and I'm just going to hit Command A, I select it all, and I'm going to go up to the Analyze drop-down menu and go Plot Spectrum. And so this is trying to show me what sort of frequency it is. And so we know, because I just made this tone, we know that it's 50 hertz. So you have a bunch of different functions. Just hand window's fine. You can do hamming. Doesn't really matter. Well, I guess it does make a difference. But this is all going to work the same way. The principle is still going to be the same. What we want to do, this size value 128, is really about like the width. It's the size in digital samples for the that it's doing the Fourier analysis of. And so we talked about how longer windows have greater accuracy in judging the pitch or the frequency of the tone. And so with this really short window, we've got really lousy accuracy. So this purple line is basically saying, well, the frequency is kind of at this end of the spectrum. And so what we want to do is increase the window length to a greater number of samples, the spectrum is becoming more and more precise. So all of a sudden, okay, we're not at the ultimate low end, but we've got a peak here, and so we're looking for a peak at 50. And as we get use a longer and longer window, that's what we're getting. So we use 20, 30, 40, 50. This line here, at peak, we've got 50, and if we increase the window even to greater degrees, it's becoming much more accurate. So we can be much more confident that that's what the frequency is. So this is a tool in Audacity that you can use. It's not particularly part of the assignment, but if you wanted to confirm the frequency of the wave file that you're supposed to analyze, and on the basis of the period that you're measuring in the waveform, this spectral analysis would be a really great way of making sure that you've got the right frequency. And so that is that.